So thanks everybody for joining at your different time zones. I will just start off again with a brief context of the session. So this one is open to all, so feel free to invite your colleagues. So we already had 2 very exciting workshop days. So this is the 3rd day of 3, where we had a limited number of accepted participants who had some Python knowledge and some bioimaging problems, and we were walking through with some Python refresher really, and then looking at the Napari assistant, and then Jupyter Notebook examples on how to visualize and interact with your data in Napari, and how filters work, and a lot of really great bioimaging related refreshers. So I hope that, or not just refresher, but really for people to start using Python more in the bioimage analysis and be able to use Napari in the process, which makes it much nicer. And all this was sort of coordinated through the LIBREhub project in a way, which is a CZI funded project where we try to disseminate open source hardware in Latin America. So we organize seminars and workshops to make people aware of that. By now there's some very cool designs available to really build your own bioimaging hardware as well. And so not only be reliant on, for example, accessing core facilities, but being able to do some work yourself and customizing it to custom experiments. And then probably, maybe sometimes with some of the samples anyways, go to a core facility too, but doing all this with open source technologies, and that of course includes software. And so there we are excited of starting to use Napari more ourselves. So we wanted to include this more software-focused workshop in our program, and I think it's been really interesting for us, and I think there's been a lot of interest by the Latin American communities. I'm sure this is not the last training we'll have had in Latin America, and this is the last day where we're going to look at, so it's less workshop style, even though it depends on each trainer how they structure the session, but we're going to see different plugins that give you particular capabilities to interactively analyze your images and data in Napari, and some things that are not necessarily 100% Napari, but interface with Python to machine control as well. So that particularly the later sessions will be a little bit on that. So how to control your microscope also with Python libraries, and use Napari for real-time control and so on. So I'm excited to hear about that as well. And with that, we start again with Juan, who has already contributed to every other day of the, so not every other day, but every of the other days, I want to say, of the workshop. Thank you so much for your very big contributions.
No worries. Yeah, okay, so I think I won't actually take my full now 40 minutes, but let's see how we go. And like with every session, I encourage people to stop me and ask questions if something isn't clear or if something is exciting and you want to learn more about it. Okay, so people can see my screen, I hope. Let's see if I can move this little zoom bar that you probably cannot see. Okay, so I'm going to talk about 2 things. One is Napari animation, which is not my project, but it's a very cool project. And actually, I remember when people started proposing this thing, I was actually very like, oh, you know, this is Napari is for like real scientific work, not for like making pretty pictures. But, you know, actually presentation is really, really important. And people want to basically give a tour of their data to tell a story. And so Napari animation has turned out to be one of our most used and most popular plugins. So it was started by Napari Movie, which was like a little standalone package by Guillaume Witz. And then Nick Sofronieff and Alistair Bird have been really leading the development since then. But actually, it's quite a quiet repo. Like the design is good enough that there's not much stuff happening with it, which is really cool. So I'll do a couple of demos and then I'll talk a little bit about how it works. This is this tribolium dataset that I showed in my first day. Let me load it. This is a very big data set. So it's actually 200 and a bit gigabytes. So when you're looking at slices, it's quite fast. But if you try to look at it in 3D, you will see that it is very slow. This is it like loading one frame. And now if I try to rotate it, it's like not very smooth at all. It takes a long time to move between frames. Whoa. Okay. So let me just set a couple of settings in terms of the rendering to make it look like how I want. So I'll do that, attenuated and a little bit brighter, like that. Okay. So
the menu is very small to see. So maybe if you just share that window or make it a bit bigger, is that possible to zoom in?
It is not possible to make the menu bigger, but I will just say what I made. I made this, I changed this from MIP, which is a maximum intensity projection, to attenuated MIP. What attenuated MIP does is that it prioritizes, it decreases the brightness of pixels that are further away from the camera. But other than that, it is doing the same thing as a maximum intensity projection, which is to cast a ray through your data and finding the maximum point. But the points that are further away get exponentially weighted down, which gives you, much more of a feeling of 3D and things that are in front of you and things that are in back, whereas maximum intensity projection treats those things the same. So you can't tell what's in front of what else, other than by the spatial context. Yeah, so that's all I've done, but it's very slow. But the nice thing about Napari animation is that it will take however long time it needs to capture a frame. And so you can get even if your data set is very slow for your computer to handle, as you can see, it takes forever to do anything, even resizing a window. Let's go start the wizard for Napari animation. We can basically go to a frame. Again, this will take a few seconds. Capture that frame. So now we've made that a keyframe. Then we go to the last frame. And for prettiness, I will rotate this. Okay. So now we're looking at the opposite side of the embryo. I'm going to say I want 60 steps, and then I will capture another frame. Okay, so what's happened now is that I've taken one frame a while back. Is this actually doing anything? Yeah. So the frame is actually capturing the viewer state at that position. And then it interpolates the viewer state across a bunch of variables, including the camera and the sliders, and which layers are visible. And so now I can click on Save Animation, make a file on my desktop, which I will call Tribolium. And click Save. Okay, and so this is actually going to take a while. And my viewer is going to be non-responsive in the meantime. So I will just talk about stuff in the meantime. So you can see it's taking about 3 seconds per iteration, which is not great. Okay, so I'll just go through. So we just showed like how to do it in the window. Part of the things with Napari is that it works really well with Python, and sometimes if you're making an animation, it can be nice to do it and then see the effect and then modify some stuff and just have a record of what you've done. So that's what you can do with code here. So here I'm doing something similar. Again, I can't run it while my kernel's going. Oh, maybe I can. Maybe it's doing it in a new thread, which is kind of cool. I didn't know this. Hang on, let me try something. No, I don't know what magic it's doing that the kernel thinks that it's idle, but it's actually blocked. But anyway, Okay. So I'll just go to this code while that's running. And so I'm opening a viewer, opening a data set using this plugin. And then I make an animation object from that viewer. And what that means, every time that I click animation.capture keyframe, it's going to read all of the status of that viewer, which layers are in the viewer, which layers exist, what the camera angles are, and then it will interpolate using some kind of interpolation formula for all of those parameters over however many steps you described. And there's this thing called ease, which you see on the bottom right, which is whether it goes linear interpolation when it goes close to the edges, or it can do some smoothing so that it stops a little bit over each particular position. So you can basically get your animation to sort of come to a spot, stop, have a look at it, then go to another spot and look at it again. So here I'm moving the slider. This is the time, Z, Y, X. So I'm moving it from the end of the Z stack to the top of the Z stack, then to the middle. Why am I? What's the size of the stack? All right, I can't actually find out right now. Then I move the time points from to the end and to the beginning. Then I switch the number of dimensions that I'm displaying to 3, and I switch the color map of the layer to the magma color map. Capture a keyframe. Change the rendering, capture a keyframe, so that each time that I do this, I will get 1 frame in the video. So you can see all of these steps happening. Actually, I might add another capture here. There you go. Change the camera, capture a keyframe, change the angles, capture a few keyframes, change the angles again. So all of these rotations will get captured in my animation, and then you call animation.animate your frames per second, and then it will run through all of those steps in the background and save a screenshot for every step and turn those into a movie. Okay, so this is now almost done. I should just get smaller sizes, but part of the reason I chose a big size is that this is a data set that my computer struggles to handle. But now if I play this movie, you will see that it is very smooth as it does it. Okay, so even if you have a data set that is not very smooth when you're interfacing with Napari, you can still make a beautiful animation as long as each keyframe fits in your RAM. All right, so now I'm going to do this other thing. So I'll close this viewer. So just to reiterate, making these keyframes here is exactly the same thing that I do here when I say capture keyframe. So I can close this, run this. Oh no, I cannot run this. Reader Napari Mizar, but return no data. Hang on, is this the wrong? Oh, this is the wrong path. Sorry about that. I'll just copy it from up here. This is what happens when you copy and paste from multiple notebooks. Okay, so you can see the viewer is doing a whole bunch of work right now. And that is because Napari animation is running through everything and capturing screenshots as we go. We can't actually see thing, but you can see the screenshots. There you go, 10 screenshots per second. I should really pick shorter things to do. we have any questions while we're waiting for this movie to come out? It will be under projects, Napari, workshop, data, data, docs, day 2, day 3. There it is.
I do have a question indeed. So I realized that you are working there with SAR files, and I wonder how the data is accessed, the file, the Napari animation plugin is being working.
Yeah, so the way that Napari works with ZAR files is you load a ZAR array, which is an array that is basically a pointer. It doesn't actually have any data. And then when we move the slider in Napari, Napari calls np.array on that particular slice of the ZAR array, so it loads the data at that point. And the data doesn't stay in RAM, it just loads it while it's displaying it. So because Napari animation is moving the slider for you, then that is exactly what it's doing to access the ZAR file. It's moving the slider, and then Napari takes care of loading the data set at that point. So it's kind of nice that, yeah, it basically, like, there's all these abstractions that mean that, like, Napari animation is not worrying about any ZAR file, only Napari is worrying about it. So that's really nice.
Thank you.
Yep. Yeah, cool, this is done. So now this should have a movie where we're going through the Z stack up and down. Then we go to the middle again. Then we're going through the time slice, then we switch to 3D and watch the embryo in 3D. Okay, the last thing that I want to show about Napari animation. So this is code from our day 2 workshop. So I'm not going to go through it, but basically we're just segmenting these cells from the Allen Institute dataset. Okay, so now we have a data set that has cells segmented and centroids and edges and so on. So what I can do is I can take off all of the processing and just show the data set. And I'm going to go to Window, Plugins, Wizard, Napari Animation, capture keyframe, kind of move a little bit, capture another keyframe. I'm going to add the edges so we can show that we've done a processing step. I'll get rid of this to make it a bit clearer. So that's the edges. Capture keyframe. And I'm going to add the points. Rotate a little bit more. Capture keyframe. Then I'm going to rotate a bit more. Add the labels. And go back to the nuclei and capture another keyframe and save the animation. So let's go back to the desktop. Let's say segmentation. Save. So this should be much faster because it's a much smaller data set. Okay, so you can see how it's adding each of the elements in as you make them visible in the viewer and capture a keyframe. So you can get some very nice, I think there's one there that I should have removed, but you can get some very nice animations of, processing pipelines or analysis results overlaid on top of your image. So that's Napari animation. Give it a try. I think it's a really cool way to get show off your data. And now I'm going to move on to affinder, which is this plugin that mostly I wrote, but it's based on an idea from Albert Cardona and Volker Hilsenstein, who was at Emble for a while. Now he's in some startup. So the idea is very often you want to align some images. And it's very tricky. There's very different modalities. So this is a worm from the Alex DeMarco lab here at Monash. And it's been imaged both with a scanning electron microscope and with a fluorescence microscope. So there's very few algorithms that will be able to look at these image features and align them together. So you basically want to, a nice way to manually align them. And the key insight was that you can click only three correspondence points in each image. And with that, you can get an approximate alignment. And after that, you yourself have an estimate of when you click in one, where the next click is going to be in the other one. So you can very quickly add additional points, correspondence points, and refine your alignment. So I'm going to do plugin start affinder. So now we get a reference layer. This is the layer that's not going to move. And a moving layer, this is the layer that we are going to stretch and align to fit the reference layer. If you already have some correspondence points, you can add reference and moving points, but right now we don't, so we leave it blank and the plugin will do them for us. And these are the different models that are available. We want to add some rigid stuff, but right now these are the ones that you can do. And optionally, you can save the affine matrix from your alignment to an output file. So I'm just going to write affine.txt and it will save it. Okay, so I start. So now what I need to do, and you kind of need to know this in the, and there's not really much of an instruction manual, but yeah, hopefully we can do something more guided in the future. But the first step is to add 3 points, and we need to add them in the same order in both images. So I'm going to add one at the start of the worm, another at the back of the worm, and then maybe another one over here. Okay, so now I need to pick the exact same 3 points in the same order in the fluorescence image. So, and if you want, you can hide the EM to make it clearer, but yeah. So go here. First point, the back, and then we did under here, right? So now if I turn on the EM layer again, you can see that they're basically aligned. Let me make the EM less bright so that it's easier to see what's going on. So in this case, I've done a pretty good job and I could just finish, but just to show you what happens otherwise, can go back to the reference points. So now I'm in the EM data. I can add a new point, and you can see that the next click is very easy for the other image because I already know more or less where I'm supposed to click. So I can just click again and get a refined thing, and I can repeat this over and over. So I can click again over here, and maybe it's over here. And this way the alignment will get more and more refined. So now I can finish. You can see that now I have this affine.txt file that has the alignment parameters. This is an affine transformation matrix from our transform, which basically converts the moving image space into the reference image space. And this is all being saved live in the layer information as we do it. So there's a affine transform parameter in each layer. And if I look at that affine, if you look at, by default, this is just identity matrix. So if I do np dot as array of EM layer dot affine, you'll see that this is just 111. So when we were doing our transformations, they were getting written to the affine transform matrix in Napari, which is how Napari was able to display the image and make it, make it stretch live as we were clicking on things. And that's actually it for me. I want to add 2 things that aren't here that I want to add in the very near future. The first one is that this works in 3D, but Napari doesn't work very well in 3D because to add correspondence points, you have to be in 2D mode, to pick the points. And in 2D mode, Napari won't show rotations that are external to the plane that you're looking at. So if you have a volume that's here and the next volume is rotated, 90 degrees in this direction, Napari can't handle that. So you won't be able to see your rotation as you're adding the points. But if you add the points at the right locations, Napari will correctly align the two layers. And then if you look at them in 3D, they will be correctly aligned. So this also works for 3D layers, which is nice. It's just a little bit less nice to use. And the other thing that isn't there yet, but I want to add is if you have some kind of similarity metric between the images, it's nice to be able to pick points to get an approximate alignment and then use an algorithm to refine the final alignment. Because the issue with a lot of these automatic registration methods is that they get stuck in local minima and they can't always find the optimum. But if you give them a head start, then they do really, really well. So that's sort of the next step for the software. And like Napari, this is fully open. So if you're interested, feel free to come help.
Very nice. Thank you very much for showing us these two very helpful tools. I think I haven't used them yet, and I think it gives very nice results to use them. Also, the animation to explain things in talks or share it on social media.